Okay, we're up and running now. Let's do the screen share. Okay, that's looking good so far. You guys should be seeing my background screen now.
Yeah, I see.
Yep.
So now I got to reload. Oh yeah, everything. Of course. By the way, I rebooted twice. So anyway, I don't know. I cleaned my Chrome cache. We'll see if that helps. Okay, now I need to do review 2. So once again, I'm sorry out there, everybody. First, yeah, this didn't go well today, but hopefully you guys should be seeing my notebook screen now. Let's see. I'm going to do away with the pictures here. Okay. I think we're actually ready to go. Now, let me just say that people in here so far have given me the following test problems to look at. They are 2, 6, 8 to 10 as a group, 18, 19, 20, and 12. If you want to add to that, let me know. I'm going to try to go in order here. The first one was test 2. So let me get over to that. Try 2. I may or may not have that. We'll have to develop. We'll see. Yeah, don't have test 2. So I will do it here in just a sec. Okay, get my keyboard out of here. Number 2. Find the equation of the line. All right, so we have for the 2 points, 3, 0.8, and 7, -6. Nice whistle, whoever that was from.
That was me, sorry.
No, that was good quality. Nice job. Okay, so you want to find the equation. Step 1 is what? To find the slope. So I'll call this point 2 and this point 1. So y2, -6, minus 0.8 over x2, 7, minus x1, 3. So -6, take away 0.8 is what? -5.2. And on the bottom, we get a 4. So what is that, -1.3? I believe it is. So now we have our slope. Okay, so now plug the slope in. And then we got everything except the y-intercept. So now I'll plug in a point. I'll plug in the 7, -6 point. Are you guys seeing everything? Looks like we're up and running finally this time, huh? Is that correct?
Yep.
Okay.
Yeah.
You're hearing me and everything? Okay.
Mm-hmm.
So when we multiply this, what do we get? 21, 2, 9, -9.1. And then add 9.1 to both sides. So the equation would be I don't usually like to do decimal problems like this, but and I did it kind of quickly, kind of rushed here. So I don't know who asked about number 2, but hopefully that answered your question.
Well, that's not what they have in the back. That
Oh, it's not. What do they have?
no. Plus 10y minus 59.
Oh, okay. So they've got the standard form of an equation. Yeah. I told you I will always go for slope intercept. Well,
Okay.
if you took, I don't want you to do this, Matt, but if you took the equation in the back of the book and solved it for y, this is what you would get.
Okay.
So I am going to be true to my word. I'm going to stick with everything I ask you is going to be for slope intercept form.
Okay.
So I'm sorry, that's one little difference between me and the book.
Okay.
I do have a question too.
Yeah, go ahead.
I put the points the other way around, and I got a completely different slope for M.
So you did 0.2 the other way? Okay, I'll do that real quickly.
Dr. Belo, I'm also confused on the one you have right here where
Did I make an error?
there's like a -6 minus 0.8, and I thought that would be a negative
It would be.
6.8.
6.8. Yeah, I see that now. So that's the trouble. I went too quick. Yeah, I did make an error here, guys. So, you know what? I apologize. A little too quick. That's what I get. So this should be negative 6.8 over 4.
7.1 or 1.7. My bad.
Yeah. Negative 1.7. Geneva, is that better?
Much better.
Yeah, I'm sorry about that. Okay, let's do the slope intercept over again. Negative 6 equals negative 1.7 times 7 plus B. 49, 4, 11. Add 11.9 to both sides, and you would get what, 5.9? So, Geneva, how do we compare now?
Much better.
Okay.
I have the same answer.
Yeah, and like I told you, it shouldn't make a difference. That is, if you do it correctly, it shouldn't make a difference, and it doesn't. Okay, that was number 2. Next one I've been asked about is number 6. So let's take a look at number 6. Wow, we have some interesting sound effects. Okay. We're supposed to find the domain of the function. Find domain. So we have to, what can't we have? We can't have a negative under the root sign. It's okay to have a 0. So 10 is okay. But we can't, here, let's just write this out. 100 minus x squared has to be greater than or equal to 0. And so we add x squared to both sides. And then when we take the square root, so in other words, you could write the answer like this. X, so you guys see why I did this? I had to, when you take the negative square root, you have to reverse the inequality sign. So what I found out is x has to be between negative 10 and 10.
Okay.
Inclusive. Yeah, did they? Yeah, and if you want to do interval notation, I don't know. That would be. Okay, that's number 6. Whoever asked about number 6, are you good?
Yep.
Let's talk about 8 through 10 in a kind of a general way, because that was the next section that was brought up. So in 8 through 10, you're supposed to approximate the intervals over which it's increasing, decreasing, or constant, and determine whether it's even, odd, or neither. So Matt, is there any particular one you want me to look at?
No, it doesn't matter. Just go over the increasing and decreasing, and then how we find like if it's an even or odd. We can just do number 8. It's fine.
Okay, well, it says use a graphing utility. So again, then not real likely that I would do.
Yeah.
But in order to tell whether it's increasing or decreasing, this almost has to be a graphical problem.
Okay.
So let me see here. What can I do? I can move this down, and I'll open up my browser. And I'll load Desmos, but I need my. All right. So now let's take a look at number 8. We have 2x to the 6th. Plus 5x to the 4th. Minus x squared. 10 and 10.
Okay.
Inclusive. Yeah, did they? Yeah, and if you want to do interval notation. So when you zoom in on Desmos, you can see where the graph is increasing and decreasing. So you see how it's decreasing from negative infinity up until what? About negative 0.3. And then it's increasing between negative 3 and 0. It's decreasing again from 0 up to positive 0.3, and then forever it's increasing. So that's the increasing, decreasing part. Matt, can you also see, if we're looking at this graphically like we are, can you tell if this is an even or an odd function? You should be able to say it's even, because do you see how it reflects left and right by, with the y-axis being the fold line?
Mm-hmm.
So I would say this is even, and that's pretty much it for number 8.
Okay, so how do you determine, like, say if it was an odd?
Well, if it's an odd, let me just throw an example on here of an odd. I mean, an obvious one is x cubed. Let me get rid of the one on the top. So when you have it like this one, this is an odd function. Why? Because every point over here on the left has a matching point up in the first quadrant. So you see how the origin is kind of the center?
Mm-hmm.
So like if we took this point right here, there's a matching point down over here. And if you connected the 2 points, you know, that you'd be right at the origin. That's odd symmetry.
Okay.
And what's different about number 11 is that's what, a piecewise? So you just have to graph both parts and see if there's, you know, you just have to eyeball the symmetry. So the only problem with 8 through 10 is I'm not going to be giving you I mean, the approach here is not my approach. I would not ask you a graphing calculator question.
Okay.
Partly because I never required. So I'm somebody just sent me a text message, and I'm answering you right now too. Will a question like number 8 on page 252 be on the test tomorrow? Not just like it, no, because of the graphic calculator, requirement kind of for the way they set it up.
So could you like just give us the graph and then say where's it increasing, decreasing, and then
Yeah,
is
that
it
would be
even
one
or
way.
odd?
That's an excellent idea. I could just give you like what you're looking at right now and say, well, where is it increasing and decreasing?
Okay.
And is it even or odd? And
Uh-huh.
that's exact. That would be a good way to do a problem like 8 through 10. Thank you. Good suggestion.
Okay.
Yeah. Okay. Let's go to number 18 next. Get back to our notebook here. Number 18. Okay, again, you guys, it's interesting. You picked all questions I don't have. Here's the equation. And the question was, does this, okay, now there were a couple of people who were online earlier and not all of you were there. So let me repeat what I told them. This is not likely to be a question I will ask on the test either. Here's why. Because the book, you probably know by now, the book is big time into will the inverse of this be a function? Well, first of all, you can find the inverse of anything. If you have a graph, you should be able to find the mirror image on the other side of y equals x. But what's more important, what they want to know is when you find the mirror image, will the mirror image be a function or not? And I couldn't care less about that. So I don't know. Maybe we should just halt discussion on. So I guess here I'll just say. So what they're into is, can you find the inverse? Sure. Can you graph the inverse? Yeah. Can you now really the only question they want to know is that inverse, will it pass the vertical line test? And I'm not likely to ask you that. What I might do is say, here's a graph. Is this other graph the inverse of that one? And you could just pretty much by eyeballing tell if it's a mirror image. I don't know. Not a great question for me again. So I guess what I'm doing here is I'm admitting that test in the book isn't as wonderful as I thought it was. But you are hearing straight from the guy who will write the test that I'm not real likely to ask you a question like just the way 17, 18, and 19 are. So I don't know. We can keep. So I just don't know if we should spend any more time on that one. Now somebody asked me about number 12. So let's go to that one next. Now that's 12 like. Here's number 12. Yeah. Number 12 is find h of x equals minus the greatest integer of x. And remember, if I put the question like this on the test, I will just use single brackets because I don't think I have the font that allows that. So when I write it like this, that means the same thing the book's got with a double bracket. So what does this mean? Okay, you remember what greatest integer means. It means find. Okay, I just got a text message, but they said, can you please show me where the graph is increasing and decreasing again? On which problem? I need to know which one you're talking about. So anyway, be more specific. I'm going to come back and keep going on this one. So how does the greatest integer work? Whatever you put in the brackets, you have to bring back the greatest integer that's less than or equal to the number. So for example, 0. What's the greatest integer of 0? 0. What's 0 times -1? 0. So that's this point right here. marking it in red. Okay, how about a half? What's the greatest integer of a half? 0. What's negative 1 times 0? 0. Okay, that's that red point right there. How about 9/10, 0.9? What's the greatest? What's this function of 0.9? The greatest integer of 0.9 is 0. What's negative 1 times 0? 0. And finally, when you get to 1, what's the greatest integer of 1? 1. And now what's negative 1 times 1? Negative 1. So you see why we wound up down there? Well, anyway, the bottom effect is, you remember our standard greatest integer was a step. It was called a step function, and it went up in this direction. Well, because of the negative, what is it? It's kind of taken the slope of the steps, and it's made it negative 1. And now you see the steps are going up, or down, whichever way you look at it, the opposite way. So once again, whoever 920-390-0850 is, can you show us how to find where the graph is increasing or decreasing? Just let me know which kind of problem you're talking about. That's when is it going uphill, when is it going downhill? But you have to ask me about a specific problem, okay? And then I'll go back and discuss that. So the bottom line is number 12 is the blue ink on here. It would be a step function, but it would have, because of this guy right here, because of that, it's a negative slope instead of the normal positive uphill slope. Okay, like a graph in section 8 to 10. I got my answer. Okay, so do I still have my Desmos graph? Yeah. So, whoever that person is, just eyeball this graph. This is, by the way, number 8 you're looking at. Number 8. When is it decreasing? When you read it from left to right, when is it going downhill? It's going downhill, this big long section over here on the left, until what? Looks like this point right here. So it's decreasing from negative infinity to negative 0.308. It's also decreasing from 0 to positive 3.8. And then it's increasing from negative 0.308 to 0. Why? It's going uphill, and it's going uphill from positive 0.308 forever. So you can just literally, once you have a graph, you can just look. When is it going uphill? When is it going downhill? That's all it means. Is it increasing or decreasing? Hopefully that answers your question, whoever you are, with the mysterious phone number. Okay. All right. So now, where was I? We finished 12. Okay, now somebody asked me about 20. I'm going to go to 20. Yeah, I think it was you, Brandon. Okay, number 20.
Yeah.
So 20 says it costs a company $58 to produce 6 units of a product and $78 to produce 10 units. How much will it cost to produce 25? So really, you could think of those like ordered pairs. 6 units, $58. There it is. 10 units, $78. 25 units, we don't know. So here's the deal. With 2 complete, I could find, and you notice the book says, assume that it's linear. Okay, let's find the line that contains these 2 points on the top. So now it's the old drill. Find the slope. Y2 minus 1. So I found out the slope was 5. And then, anyway, you get the whole equation. And then, how do you find out what happens when x is 25? Just plug in 25 and happy arithmetic. And you get your answer, 153. So hopefully that's enough So that actually would be a pretty decent word problem for me to include because it checks on your knowledge about a line and how to form a line, how to find the equation of a line given 2 points, and it also allows you to show your problem solving skills. Excuse me.
So in that problem,
Yeah.
I had an easy time when you imagine the arithmetic. I'm sorry, I got an echo. Anyway, I had an easy time with understanding the arithmetic, but it's hard for me to visualize what exactly the word problem wants me to do. Like when you put it in ordered pairs, it's pretty easy to understand, but how do you identify it to the level where you can get it to the ordered pairs?
Yeah, the way you would do that is if you look at the problem, they give you 2 pairs of numbers?
Right.
Pairs of numbers. What do I know that has pairs in it?
Okay.
Ordered pairs.
Okay.
I would say that I'm just trying to simulate. That's really how I think a person has to do it.
Okay. Okay.
Okay, I think I have at least looked at all the questions that were asked. If not, remind me. I'm trying to keep track of things. And once again, I'm sorry about the aborted beginning of this thing. What should we do next? I know some of you did review questions. We can certainly go through some of those too. Those are excellent also. Any questions out there? What would you like to do next? By the way, a couple of you, while I was rebooting 2 or 3 times, were sending me messages like, if we can't do this, are you going to cancel the test? The only reason I didn't answer you is because I was rebooting 3 times, okay? So, and had we not been able to get this second time running, yeah, I would have, I'm sure we would have had a review session tomorrow. But,
I have a question.
oh yeah, go ahead, Matt. Oh, and I see I've got one online, number 13. Okay, thank you, whoever sent number 13. Go ahead, Matt.
You can do theirs first. It's fine.
You sure?
Yep.
Okay. Number 13, everybody. I'm going to make a slide for that. Change that color. Okay, number 13. H of x is equal to negative square root x plus 5 plus 8. So what you're supposed to do is kind of break that up into separate functions and make a composite out of it. So again, like I did the other day, I would want to start in the very inside, and the first thing that's really going on is right here. So let's call that my f of x. Take whatever I give you and add 5. What's the next thing that happens as you move out from that? Take the square root. So I would say let's have g of x be take whatever I give you and take the square root. What's next outside of that? I maybe shouldn't. Let's use j of x. Multiply by -1. That's this guy right here. So take whatever I give you and multiply it by -1, which of course we could just write like this. And then there's one more function, let's call it k of x, and that is take all of that and add 8. So really, there's 4 things going on up there. And so you could say that h of x, h of x, oh, sorry, h of x, lost my pen. Oh, I see what happened. No, maybe not. Let me this keyboard off of here and see it. All of a sudden, I lost my pen. Anyway, h of x, now I got to put this together. Let's see, can I write with my, I'm going to try write with my mouse. So h of x equals, so the we want to do k of j of g of f of x. You know, it's just saying put them together from bottom to top, you know, inside out. Now, the other part of this question was, what does the graph look like? Okay, so I think you can see that this is a square root function. I mean, the main feature of this is right here. I can't get my pen to work, sorry. Let me try this battery. Well, you name it, it's happened today. Okay, take the battery out. We'll give it a jostle. Let's see if this works. So the main, yeah, that did it. So that's the main feature of that. And now you guys know that that looks like what? Like this? Right? It's a half of a parabola laying on its side, the square root of x. What's different about ours? Instead of starting at the origin, this tells me start 5 units to the left. Okay. What does the negative tell me? Instead of going up, go down. So, you know, you see what's going on here. So overall, we got this graph. So instead of starting here, we're going to start 5 to the left. Just make believe this is -5. Okay. We're instead of going up, we're going to go down, but it's up 8. So if we go up here to 8, so it starts -5, it goes down. So the graph, you know, I got too much up here. So this thing's going to look something like this. Do you follow? So just to go through it again, it's a square root. It's an upside down square root because of the negative. It's moved to the left 5 because of this +5, and it's shoved up 8 units. So if you get the picture here, this is negative. This is the point -5, 8. That's where the graph's going to start. It's going to be one of those half parabolas, but it's a downward one because of the minus sign. So that kind of completes what number 13 was supposed to look like. Matt, did you want to bring back your question or bring up your question?
Yeah. Could we go over like in part D?
Part D of?
Number 15.
Oh, 15D? Got it.
Yes.
Okay. So here's 15, I think.
Yep.
Except I've got E there, but I mean those are the two functions. 3x squared minus 7 is f, and g is -x squared. Okay, so those are our two functions. So I'll tell you what, I'm going to duplicate this page, and then we'll do the part D that you wanted. So let me clone this. And now I'm going to erase all the stuff on the bottom. Okay. except I don't have my keyboard on. And let's erase this. And we're going to do D. Okay, finally I'm there. Okay, so what does part D say? Find F divided by G. So find F slash G of X. So that's just this guy over this guy. So we start off just by putting one thing over the other. Now, is there anything we can do to simplify this? Well, I don't know. I think I would attempt to factor. Let's just see. Maybe we can simplify this. So we could take out, it's not looking real good though with the top. Yeah, there's just no way, even if we factor the bottom, we're not going to be able to, we can't factor the top. But what we could say is that this denominator can't be 0. So let's just do that. Negative x squared minus 4x plus 5 cannot equal 0. We know that. And if let's just simplify that a little bit. When might that occur? Well, let's multiply both sides of this by -1. You know, right now we're just we know we want not equal, but you know we're going to just set it equal because we know what we want to find out when it would equal 0. Okay, so if I multiply both sides by -1, and then it looks like I can factor that, and it's what? Plus 5 minus 1. So what are the two things? X equals -5. X equals 1. So now I know what X can't be. So let's just go up here and say X cannot be -5 or 1. So I would say this answer is now complete for part D, Matt.
Okay.
And I don't have the time to check in the back, but I'm guessing that's
what they had.
Yeah. Yeah, thanks for the questions. What else should we go through, guys? Well, maybe now that's 12:30. That's about, we lost 10 in the middle there. We're about at the right spot here. One more time. What other questions would people out there like to ask? Okay, then I'm going to stop the broadcast. And obviously, this video that you've been watching live is the one that I'm going to publish, not that aborted first one. Sorry about the difficulties today. Guys, thanks for hanging in there. I appreciate it. See you on tomorrow.